What would happen if Earth entered a black hole? At first, nothing strange would seem to happen from our perspective. But as we got closer, gravity would become extreme. Time would slow down, and space itself would stretch. This process is called spaghettification, or tidal. Forces would stretch Earth and everything on it into long, thin streams. Eventually, we would cross the event horizon, the point of no return, where even light cannot escape. From there, Earth's fate would be sealed inside one of the universe's most mysterious objects. Today we will talk about what if Earth entered a black hole. So before we start, make sure to hit the like button and subscribe to my channel. 1. Introduction. A journey into the extreme unknown. If Earth were to enter a black hole, it would experience one of the most extreme and destructive processes known in physics. Black holes are typically formed when massive stars collapse at the end of their life cycle, compressing enormous mass into an incredibly small volume. There are different types, including stellar mass black holes, which are a few times the mass of the Sun, and supermassive black holes, which exist at the centers of galaxies and can be millions or even billions of times more massive. If Earth somehow drifted towards such an object, the outcome would depend heavily on the black hole size. However, regardless of type, the fundamental physics of extreme gravity, space-time curvature, and tidal forces would dominate every stage of the experience. 2. The approach, gravity, space-time, and distortion. As Earth begins its journey toward a black hole, gravitational forces would start to dominate all other interactions in the solar system. According to Einstein's general theory of relativity, gravity is not just a force, but a curvature of space-time itself. As Earth approaches the black hole, this curvature becomes increasingly severe. Time dilation would begin to occur, meaning time would pass more slowly for Earth compared to distant observers. Light from Earth would become increasingly redshifted, losing energy as it struggles to escape the gravitational field. Meanwhile, tidal forces would begin acting unevenly on the planet. The side of Earth closer to the black hole would experience significantly stronger gravity than the far side, creating a stretching effect even before any structural damage occurs. Oceans would shift dramatically, the atmosphere would begin to deform, and satellites would be pulled out of orbit long before Earth reaches the critical boundary of destruction. 3. The Roche limit. Planetary destruction begins. As Earth moves closer, it would eventually cross the Roche limit, the distance at which a celestial body's internal gravity can no longer withstand the tidal forces exerted by a larger mass. At this point, Earth would begin to break apart structurally. The crust would fracture on a global scale, tectonic. Plates would lose coherence, and massive earthquakes would ripple across the entire planet. Oceans would no longer remain stable bodies of water. Instead, they would be stretched into massive streams, some of which would begin spiraling toward the black hole. The atmosphere would be stripped away almost instantly, forming a glowing halo of ionized gas. This material would not fall directly into the black hole, but would instead form part of an accretion flow, heating up due to friction and emitting intense radiation. 4. Spaghettification, the ultimate stretching effect. One of the most visually dramatic and physically extreme effects near a black hole is spaghettification. This occurs when tidal forces become so strong that they stretch objects vertically while compressing them horizontally. For Earth, this process would become absolute. Mountains, oceans, and eventually even molecular structures will be pulled into long, thin streams of matter. On a human scale, bodies would be stretched into atomic filaments before being torn apart at the subatomic level. The reason for this is the exponential increase in gravitational gradient as one approaches the black hole. The difference in gravitational pull between 2 points only meters apart becomes enormous. Even atomic bonds would not withstand these forces, meaning matter would cease to exist in any familiar form.